Okay, guys, we are going to dive into the world of rules for exponents now. We're going to start with a rule called the product of powers rule for rules for exponents. Okay, so just to kind of get us off and running here, okay, product, you should remember that product means multiply. Okay, when you see the word power, power means you're going to see an exponent in there. So if I take a look at this right here, x to the third power, that's a power. Okay, so when we're talking about the product of powers rule for exponents, we're going to be multiplying powers. Okay, that's going to be our rule. Now, the first thing you need to know about this rule, guys, is that the bases, in order to apply this rule, the bases must be the same. Okay, and what I mean by bases must be the same. What I mean by the bases, okay, are really the variables. Sometimes you're going to have obviously problems with numbers, but really the variables. So in this little example I give you, the bases of each of those powers are x. So that means the rule is going to apply. I can apply this property. I can apply the rule. I'm just going to basically show you the long way for this problem, just really to show you why the shortcut works. Okay, I'm not going to expect you to do it this way. So if I took this problem and I expanded it out, x to the third power, that first x to the third power would be x times x times x, right? That second x to the third power would also be x times x times x. Now remember, you're multiplying those two together. The parentheses are just separating those two, so I could take them away. I'm going to strip away those parentheses, okay? And if you count them up, you have 1, 2, 3, 4, 5, 6 x's. So obviously that's going to be x to the sixth power. So really what we're saying there, guys, is x to the third power times x to the third power is equal to x to the sixth power. You do not need to do any of these middle steps. If we were in class right now, I'd say, what do you think the trick is? What do you think the shortcut there is? And hopefully a bunch of hands would go in the air and you would say, well, Mr. Reagan, the 3 and the 3 add up to equal 6. That's exactly the rule. The rule is when the bases are the same, we add the exponents. So if I had a to the m power multiplied by a to the n power, that is going to be equal to a to the m plus n. That's the rule. Okay, just remember the bases have to be the same. You'll see when we start looking at these examples right now, the bases have to be the same in order to apply this rule. Okay, so in number 1, and let me get myself a pen here. All right, good. Okay, so number 1, okay, get all these scratch marks out of there. All right, so in number 1, the normal numbers, the regular numbers, in this case, the 3 and the 4 in number 1, they are regular numbers. You treat them like regular numbers. So since this is a multiplication problem, which all these problems are right now, you're going to multiply. So number 1, the 3 times the 4 is going to be 12. Okay, the 3 times the 4 is going to be equal to 12. Okay, and then you got the v times the v squared. If there is no exponent, that's an invisible 1. So that would be v to the 1 plus 2. The bases are the same, so I could use the rule. I can add the exponents. That's going to be v to the third power. So your final answer is 12v to the third power. Okay, so that's my answer for number 1. Number 2, okay, 4 is the only regular number in the problem. All right, so really nothing's going to happen with the 4, so I'm going to drop that down. I have an x to the second, and I have an x. Okay, that would be an x to the first. Okay, x to the second, x to the first, x to the 2 plus 1. 2 plus 1 is 3. So there's going to be an x to the third in my answer. And then I look at my y's. There's a y to the second, and there is a y to the third. That would be y to the 2 plus 3, which would be y to the fifth. So there's a y to the fifth in my answer. So your answer for number 2 is 4x to the third, y to the fifth. Okay, now normally, if we were in class right now, Some people would say, well, Mr. Rankin, isn't this term right here separated from that term right there? Just keep in mind, guys, this is a multiplication problem. Multiplication is something that we call commutative. All right. And that just basically means you can rearrange multiplication however you want. Okay. And I'll explain what I mean in number three, because number three has a lot of action. Okay. So in number three, okay, I can rearrange this however I want to make it convenient for me to work with. So if I want to do this, I can. I can take the 4, the 3, and the 2. I can put them together in the front. The 4, 3, and 2 are now in the front. Then I can put the p's next to each other. P to the second times p to the fourth times another p to the second. So I've moved the p's around. Then I can look at the q's. Q to the fourth times q to the second times another q to the second. So now the q's are gone. And then I can deal with the r's. R to the second power, r to the third power. Okay. Multiplication is commutative, means you can rearrange it however you want to make it easy for you. Okay, so the 4 times 3 times 2, 4 times 3 is 12, 12 times 2 is 24. Okay, then I can tackle the p's, right? I would add these up. Okay, they all have the same base, so I'm going to add them all up. 2 and 4 make 6, 6 and 2 make 8. That would be p to the 8th. So I'm done with the normal numbers. I'm now done with the p's. Then I take a look at the q's, same thing. I'm going to add those up. Okay, q to the 4 and 2 make 6, 6 and 2 make 8. So I got a q to the 8th. And then the r's are last. I'm going to add that 2 and that 3. That would be r to the 5th power. So your final answer for number 3 is 24 p to the 8th, q to the 8th, r to the 5th. Okay. Usually what I do, especially when the problems get a little crazy like they do in number 3, where you got a lot of action, right? You got 3 different variables, you got whole numbers, and you got a lot of organizing to do. I usually make the reference of a supermarket, right? If you walked into a supermarket in the produce section, okay, there's not just one giant bin of fruit or one giant bin of vegetables. Everything's separated and organized by category. Okay, the apples are with the apples, the bananas are with the bananas. Okay, the cantaloupes are with the cantaloupes, and so on and so forth. You get the idea. So when you're doing these problems, that's really what you're doing. You're organizing them into categories. Okay, so kind of like I did in number 3, I put the whole numbers with the whole numbers. I put the p's with the p's, the q's with the q's, and the r's with the r's. Okay, I separated them first. I organized my work. All right, and then I applied my rule. As long as they're the same base for today, you can add the exponents. Okay, hopefully this makes sense, guys. And if there's any questions, obviously, make sure that you reach out.